Today I want to teach you how to identify different types of conic sections and also how to find co-vertices, vertices, directrix, or other things related to conic sections. Today specifically we're going to talk about ellipses. So we're going to say ellipses. So this lesson is about conic sections, ellipses. We have two types of ellipses. We have a horizontal ellipse, so this is just like a sketch, and we have a vertical ellipse. We also have ellipses that are rotated, that are at angles, but in this lesson we're just going to talk about horizontal and vertical ellipses. And don't forget, always label your x and y axis, because the axis can be polar axis or imaginary. So always, if it's a Cartesian coordinate system, just label it, or rectangular, label it as y and x and y. So let's talk about different kinds of ellipses and what are the characteristics of an ellipse. So if it's a horizontal ellipse, then it has a center. So always it has a center, like a circle, it has a center. And then the long side, so the ellipse has always a long side, and a short side, right? So always the long side, so this, you can just like use another color. This is called the major axis. Major axis, right? So always the long side is called the major axis. And I'm just going to write major so it stands out. And the short side, it's the minor axis. So the long side is the major axis, the short side is the minor axis. And it's the opposite. So this one, the horizontal one, is the major. For the vertical, for a vertical ellipse, it's this vertical line. It's the major axis, minor axis. Now we're just talking about a horizontal ellipse. So then we're going to talk about a vertical ellipse. Along the major axis, these two ends, so the place where the major axis intersects with the ellipse, those two ends are called the vertices. You can say V1, V2. So we call them vertices, like vertex and the plural vertices. So V1 and V2. And then the short side on the minor axis where it crosses the ellipse, it's called co-vertices. So CV1, CV2. So all these co-vertices are along the short side and the vertices are along the long side. And on the major axis, where there are the vertices, there are foci, or focus for single. So there's F1 and F2. Now we're going to talk all about these, like what do they mean, what's the meaning of it. So from the center to one of the vertices, it doesn't matter, because from the center to this vertex and from the center to V2, the distance has to be the same. It can't be that this is 2, this is 1. No, if this is 2, this is 2. So from the center to either vertices, so it's A units, and this is A2. From the center to one of the co-vertices, it's B units. And from the center to one of the foci, doesn't matter which one, if you can see it, it's C units. Don't get confused with this C, it's the center. This C, it's the distance from the center to one of the foci. All right. Now let's just do an example, or I can first show the vertical one too. If we have a vertical ellipse, this is the center, this it's the major axis. This, it's the minor axis. Okay. This, distance. So distance from V1, or now our vertices are along the major axis, which is a vertical line, right? So it's going to be, and the major axis is just dashed line. It's not like a literal like line through it. So this is A, co-vertices. This is B, and let's say this is F1, F2 for foci. This is C. There's another important piece that I need to tell that it's going to really help like in solving problems. It is that A squared minus B squared equals C squared. This is like kind of like the Pythagorean theorem, but it's just like minus instead of the plus. And for ellipses, A is always greater than or equal to B. So we can just say A is always greater than or equal to B, and always like greater than 0, of course. All right, let's just do an example, like a quick example, and see what these look like. And okay, let's say that we have, oh, and I need to show you the equation first. So the equation of an ellipse, it's x squared over a squared plus y squared over b squared equals 1. This is the equation of horizontal ellipse centered at the origin. So this is centered at the origin. And now vertical ellipse centered at origin is y squared over a squared plus x squared over b squared equals 1. So whenever a squared is in the denominator and the numerator is x squared, it's a horizontal ellipse. It's always like that. And whenever the numerator of a squared is y squared, it is a vertical ellipse. You can also switch this here, because it's a plus sign, so you can just move the places. But whenever you see that the larger number, because a is always greater than before the ellipses, and greater than or equal to, and then whenever y is above the larger number, it's vertical. Whenever x is above the larger number, it's horizontal. But we can't have the center not at the origin. That case would be x minus h squared over a squared plus y minus k squared over b squared equals 1, and x minus h squared over b squared plus y minus k squared over a squared equals 1. So this is horizontal, this is vertical, centered not at the origin. Okay, now let's jump into an example. So let's do red. So example. Now we are given some information, and then we want to know, we want to find an equation for the ellipse. So find an equation for the ellipse with foci at 0, plus or minus 2. That means at 0, 2 and 0, -2. And vertices at 0, plus or minus 3. First of all, I recommend that you draw a sketch. X. So foci at 0, plus or minus 2, so it's going to be 1, 2, 1, 2, right? So 0, 2, 0, -2. You can just say F1, F2. Vertices at 0, plus or minus 3, so 1, 2, 3, V1, 1, 2, 3, V2. Here you can see, okay, from, and you can now find, I forgot to say, your major axis I can just say right here that major axis is 2A and minor axis is 2B. Okay? So major axis is 2A, minor axis is 2B. So we can see that our major axis now, so our major axis is from V1 to V2. Now let's count. It's 1, 2, 3, 4, 5, 6, or just 3 plus 3, 6. So our major axis is 6, and we know that our major axis is 2A. So if 2A is 6, then A is 3. So we found our A. That's great. Now let's see our C. So from distance from one we said that if this is the foci, F1, F2, this is the center. So the distance from one focus, let me do like that. So the distance from one focus to the center is the same as the distance from this focus to the center. So if we add so the distance from this F1 to F2, if we divide it in half, we can get C, distance from the center to F1, right? So if we know the distance from F1 to F2, which is 4, so 2 plus 2, 4. If we divide it in 2, we can get the distance from the focus, one focus, to the center. So 4 divided by 2 is 2. So this is my center at the origin. So we can just say center is at 0, 0. So center is at 0, 0. And then we can see that I said whenever the major axis or the vertices are on the vertical axis or the vertical line, so are vertically, then your ellipse is a vertical ellipse. Okay, so then we said that our ellipse is a vertical ellipse. So our ellipse is going to be something like this, correct? And these will be, this will be C1, CV2, sorry. So like co-vertices. And now we know our C, let's use another color. So from our center to one of the foci, it's C, right? C units. So our C is 2. Our A is 3. We said A squared minus B squared equals C squared. A squared is 9. We don't have B squared. C squared is 4. Now 9 minus 4 is 5. So B squared is 5. Correct? Now our equation, it's centered at the origin. So it's going to be x squared plus y squared equals 1. Because it's a vertical ellipse, a squared goes below y squared, and our a is 3, so a squared is 9. B squared is 5. This is your equation for this ellipse. And now let's find our covertices. Our b squared is 5, so our b is rad 5, correct? So we go rad 5 units to the right and rad 5 units to the left. So now let's see. Our CV, or covertices C1 and C2, would be plus or minus rad 5, comma 0. And I just want to give a quick hint that if your center, your center is at 0, 0, right? And whenever your foci and vertices, they're given, and the y value changes, not the x value, so the y value changes, not the x value, that means that it is a vertical ellipse. And then you can see that center is at 0, 0, but for the covertices, the x value changed, not the y value. That means it's a vertical ellipse. But if your y value changed for covertices and your x value changed for the foci and the vertices, then it's a horizontal ellipse. And the major axis in this case is 6, and our minor axis, is 2 times this, so it's 2 rad 5. So it's 2b, which 2 times rad 5 is 2 rad 5. And I hope you liked this video and it was helpful. In the next videos, I'm going to talk about hyperbola and circle and parabola, but this video was about ellipses. I hope it was helpful, and thanks for watching. If you liked it, subscribe it.